Hello, seventh graders. In this video, I'm going to guide you how to do the virtual lab fan cart physics part 2. So you should do the part 1 before doing the part 2 because the part 1 is an introduction to the whole activity. All right. So in part 1, just a quick recap. We studied the Newton's first law of motion. In this part 2, we're already going to study the Newton's second law of motion. But in first law of motion, it states that an object at rest will remain at rest and an object in motion will remain in motion unless there is an unbalanced force. So what we applied on it is just balance force because we want to see if the object is really going to remain at rest or it's really going to remain in motion, in constant motion, when the force is balanced or there is no unbalanced force. So to demonstrate it to you quickly, so I have here a cart with no fan, meaning there is no applied force acting on it. It's just the gravity and the normal force. So we're going to start with at rest and we will see if there will be velocity. So as you can see, the time is progressing, but it's still at rest, meaning it's not changing its velocity to zero. Now, let's see if uh, it has initial velocity, meaning it's already on the move. Okay, will it stay on the move and not speed up or slow down? So as you can see, it's not speeding up nor slowing down. Okay, now even if we apply or we put fan on it, but to make it balance, we have to reverse the other fan. So as you can see, they're opposite to each other. So they're kind of pushing each other, kind of similar to the tug of war when you're pulling the rope on the opposite side. So this is still a force balance. And if we're gonna start with object at rest, you will see that it's still not leaving the spot because the force is balanced. Okay, and object in motion, so this has initial velocity. We will see that it's still not speeding up or nor slowing down. So that's the first law of motion. Okay, now we're now gonna go to second law. So again, if you haven't done the part 1 yet, do that first before doing the part 2. Okay, so let's now go ahead and do the Newton's second law of motion. So we will click reset and then set the initial velocity of the cart to 0. Okay, when you open your gizmos, it's on 0 already, so you don't need to change it. And then place 3 fans on the cart. Should be all blowing to the left. So I'm gonna reverse the B, so it's gonna blow to the left too. And then put C on it. So by default, it's all already blowing to the left, so we don't have to adjust that anymore. Okay. And then the question you have to answer is, how do mass and force affect acceleration? So let's do this initial experiment first. Okay. Turn on the fans, click play, and watch the cart, then select the table tab. Okay, so it's already on, and then we're gonna play it. As you can see, you will notice that it's getting faster. Now, in the table, click the table tab and scroll down from the very bottom. So this is the start, and we want to know the final result, what happened to the last part. So letter A, scroll to the bottom of the table. How long did it take the cart to reach the end of the track? So we're gonna look at the time. This is the time. So click pause and then record the time. And then letter B, what is the final velocity of the cart? We're gonna look at the third column. So this is the velocity. So click pause again and record the velocity here. And then letter C, what is the final acceleration of the cart? The acceleration is on the fourth column. So this is the final acceleration. Click pause again, and then record the acceleration. Now let's do the hypothesis. So for form hypothesis. Okay? So you should do this before doing the experiment part. Okay? So hypothesis A, how do you think changing the mass of the cart will affect acceleration? So do you think if we add more mass to the cart, will this acceleration increase or decrease? And how do you think the number of fans amount, or it is affecting the amount of force will affect the acceleration? So do you think if we have less fan, there will be more or less acceleration, or if there's more fan, there will be more or less acceleration? So that's what you're gonna have to put in here. So click pause for you to write your two hypotheses in here. How does the mass affect the acceleration? How does the force affect acceleration? So at this point, we're now gonna do the experiment. So we will test how the force and mass affect acceleration. So select the bar chart and turn on the shown numerical values. And then for each of the situations below, you will record the accelerations of the cart. Okay, we're going to reset it. All of them have three fans, but on the first two or first three data, there's no block yet. Okay, and the rest has blocks already. Okay. All right, so I'm just gonna show you how to do it once. And then if you think you can already do it on your own, you can adjust the load and also the number of fans on. Then you can go ahead and do the acceleration on your own. Okay? So let's try this. Data number one. Only one is on. Three fans, zero block, only one is on. So I'm just gonna keep the A on. All right, so acceleration is 0.40. So click pause and record the data here. And then next would be same thing, but two fans are on already. This time acceleration is 0.80. So click pause and record the data. And then next would be still three fans and zero blocks. This time all of it are already turned on. Okay, and the acceleration is 1.20. So pause and record it here. Okay, now on this data 4, we're already gonna add two blocks. Okay, all right. So we're gonna go back to one fan on. Okay, so notice that uh the acceleration is 0.20. Okay, and with the three fans and two blocks, two fans are on. So acceleration is 0.40. And this time, three fans are on. Acceleration is 0.60. Okay, so record it in here. And now let's analyze the data. So letter A, how did doubling the force affect the acceleration of the cart? So for you to compare doubling the force, you will have to compare your data 1 to data 2, or your data 4 to your data 5. So what happened when we increase the force, meaning we turned on two fans instead of just one, what happened to the acceleration? Did it increase or decrease? Letter B. A cart with two blocks and three fans has twice the mass as a cart with just three fans. How did doubling the mass affect the acceleration of the cart? So we will compare the data 1 to data 4, okay? Or data 2 to data 5. But I think the best thing you need to or you have to compare is the data 3 to data 6. Okay? So this is what I suggest for you to compare, for you to have a better comparison. Okay? So we double the cart with two blocks and three fans has twice the mass as the cart with just three fans. So we're comparing actually the data 3 to data 6. So what can you say about the acceleration of this? All right. So the data that you're only gonna comparing is data 3 to data 6. So did the acceleration increase or decrease from data 3 to data 6? Okay, remember the difference between the two is has this one has twice the amount as this one. Okay, but they have equal force exerted on them. So what is the comparison for the acceleration? Okay, and now in number 5, we're gonna collect some more data. You will select the description tab on a simulation pane and turn on show mass. So it will show you the total mass of the setup. This lists the total mass of the cart. Each fan exerts a force of 4 newtons, and 1 newton is the force required to accelerate 1 kilogram object at the rate of 1 meter per second squared. So for each combination, you will record the total force. So since each force is 4 newtons, two fans is 8 newtons. So this one is 1, so just 4 newtons. And this one is 3, so that's a total of 12 newtons. Okay, and then we will record the mass based on the load that we have, and then we will measure the acceleration. Okay, so let's start with the two fans and zero block. So I'm gonna remove the blocks and remove one fan. Okay, so the total mass is 7.5 kilograms. Okay, let's measure the acceleration. So acceleration is 1.07 a meter per second squared. Okay? And then the next thing that you're gonna do is for the m times a, you will multiply 7.5 to 1.07. So it's gonna be 7.5 times 1.07. Okay, the answer is 8.025. Or we're just gonna put 8.0. Okay? All right. Now, you are gonna do the same thing with the rest. I will show you the data later on. But the next thing you're gonna do is what do you notice about the force and the product of mass and acceleration? What do you notice with with the force and the product. Are they the same or at least close to one another? And then draw conclusion. So Newton's second law states that the force is equal to the mass times acceleration. So this law can be rearranged as acceleration equals force divided by mass, or acceleration equals force, just another symbol for divide by mass. And how does this experiment demonstrate second law of motion? So the second law states that acceleration is directly proportional to the force, meaning as the force increases, the acceleration increases. And indirectly proportional to the mass, meaning as the mass increases, the acceleration decreases. All right? So at this point, you can now continue the rest of the data, and the rest of the video will show how to determine this two set of load. Okay, so we have one fan and two blocks. Okay, the mass is 10 kilograms and acceleration is 0.40. Okay, so divide 10 by 0.4, multiply 10 to 0.40, and that will be your M times A. Next one would be three fans. Make sure to turn them on. And then one block. The total mass would be 15. And then the acceleration would be 0.80. Okay. And then multiply 15 to 0.80 and you will get this. And then you can proceed with answering the rest of the questions. All right, so that's all for our fun card physics part 2. Again, the conclusion in here should be related to the Newton's second law of motion, which is the relationship of acceleration to the force applied and to the amount of mass. Okay, so if you have any question, just send me an email and I will get back to that as soon as I can.